Today I will run through 3 different questions involving the equations of motion, also known as the SUVAT equations, because S-U-V-A-T. And the equations of motion are concerned with Newtonian physics, so everything to do with motion of objects, forces, acceleration, distance covered, and so on. And are predominantly used when objects are accelerating or decelerating. In other words, not moving at constant speed. Constant speed, the equation you would use is speed equals distance over time. But for all other instances where an object is moving where there isn't constant speed, so the resultant force is greater than 0, acceleration or deceleration, then you have to turn to the SUVAT equations. So before we look at the questions, let's define what the symbols are. S is not speed in this instance, it is displacement. And displacement is distance in a certain direction, so it's a vector. But you can think of it as distance for the level questions you see at GCSE physics and grade 10. U is the initial speed. Then we have V is the final speed, A, acceleration, and then finally T, unsurprisingly, time. Displacement is usually in meters. Initial speed, meters per second. Final speed, meters per second. Acceleration, meters per second squared. And then time, it's always in seconds. So for the 3 questions that I'm going to go through, I'm going to show you the same method for each one, and it's really straightforward to follow. Question 1. A person begins moving after initially being stationary. The person accelerates at 0.5 meters per second squared over a distance of 9 meters. What is their final speed? This is how you work out which equation of motion, which SUVAT equation to use. You list the variables down the side of the page like this, and you fill in the things that you have and the things that you want. And then you look which letters that you have, and then you can pick the appropriate equation. So what do we have from this question? We are told that the person is initially stationary, so therefore the initial speed must be 0. We are told that the person accelerates at 0.5 meters per second squared. So A is 0.5. We're also told the distance, which is 9 meters, which is S is 9. And then we're asked for the final speed. So the final speed is V. So this thing is the question mark. So what about T? Well, there is no mention of time in the question, so we don't need that variable, so we can cross it out. So we need an equation with S, U, V, and A. So just to go back, and by the way, I've attached the equations of motion as a PDF below this video, should you need them. If we go back, the equation we need, which has S, A, V, and U, is this one, is number 4. So that's the one I'm going to use. So let's plug the numbers in. V squared minus U squared equals 2AS. Then V squared minus 0 equals 2 times 0.5 times 9. So V squared equals 2 times 0.5 is 1. 1 times 9 is 9. So V squared equals 9. So therefore V equals the square root of 9, which is 3 meters per second. Number 2. A plane accelerates at a rate of 5 meters per second squared from an initial velocity of 120 for 23 seconds. How far did the plane travel? So same thing again. S, U, V, A, T. We have the initial velocity as 120. We have the time as 23. We have the acceleration at 5. We have the how far did the plane travel? So S, the distance covered, in other words, the displacement, that's the thing that we want. And you will notice there is no mention of V. It doesn't ask for final velocity. So what can I do? I can cross that out. So I need something with S, A, and T. Let's take a look at the equations again. S, A, and T. So we can see that number 2 is the choice for this one. So let's put the numbers in. S equals UT plus a half AT squared. So S equals 120 times 23 plus, notice I put brackets in to separate the bits out, a half times 5 times 23 squared. So the final answer is 4,082.5 meters. Number 3, I am not going to do this. So please have a go at this question using the method I've outlined, and then check your answer against the mark scheme I have attached below the video. I hope that was helpful, and I will see you in the next one.